All right, so ladies and gentlemen, welcome back. This is the second part of our Ohm's Law classwork. This is going to be the section where we talk about and kind of practice using Ohm's Law. All right, so some of you hopefully had a chance to go through this if you were able to attend live class. If not, this is your chance to kind of go through it. So we already talked about in the first half of these notes, we talked about the idea that there are three kind of things that matter for kind of circuits at three physical quantities. Voltage is one. That's basically how much push there is of the electrons through the circuit. This second one was resistance. That was basically how easy or difficult it was for electrons to move in the circuit. And remember, that's just a physical quantity of the circuit itself. And then finally, you had the wires, which the wires will allow a path for current to flow through in the circuit. And so that last piece was the current in the circuit. And that was literally the amount of charge or electrons that move past a certain point in a certain amount of time. So that's basically like the electricity. And all three of those things combine to form what we refer to as Ohm's Law, which basically is defined as the amount of current in a circuit is dependent on the voltage provided by something, might not necessarily be a battery, divided by the resistance of the circuit. Okay, so these are all little practice problems we're going to work through. So the first piece of this is I actually want you to just rewrite Ohm's Law if you can. So literally, you can just copy it down from the first part. All right, but we're going to rewrite it just that we have it available. All right, so that just be, in our case, we said current is just equal to V divided by R. And actually, up top, I have the three different forms of Ohm's Law, all one if you're solving for a different thing. Okay? So, let's start by having a circuit. Just one circuit, and this circuit has one light bulb in it. And it's powered by a 3-volt battery. Okay? Now, I decide I don't want to use that 3-volt battery anymore. I want to switch it out for a newer 9-volt battery. All right, and I just want to think about what will happen. So take 20 seconds, pause the video, or just think about it for a sec or two. What's going to happen if I switch out that 3-volt battery with a 9-volt battery? All right, so hopefully you thought about it, and if I switched out that low voltage for a higher voltage battery, if we look at this formula, if I keep everything else the same, so the resistance is the same, the voltage goes up, that means the current also is going to go up as well. So it's going to basically push more electricity through the circuit, which means if we think about it in terms of the light bulb, how that will affect the light bulb is probably the light bulb will look brighter. Okay, and we haven't really talked about the idea of electrical power yet, but we're going to find out that that kind of relates, how bright that light bulb is going to relate to how much power it uses. All right, now let's say the second piece of this, let's say all of a sudden I'm in my house and I've just gone completely insane after being inside and kind of in quarantine for too long, and I decide that all the copper wiring in my house needs to be replaced with my own hair. All right. Now, besides the increased insanity of the situation, what is going to actually increase in this circuitry? Okay. And hopefully, just kind of take a sec to just kind of think about it. All right. But hopefully, you immediately recognize the idea that probably if I'm switching from copper, which is a conductor, to human hair, which is not a conductor, it's probably an insulator. All right, that's going to greatly increase the resistance in the circuit. All right, which means if I'm keeping the voltage the same, that is more than likely going to cause the current to drop dramatically. All right, because the resistance is so much higher. Now, for the next piece, we have 8 little practice problems. Okay, and what we're going to do is I'm going to do the first one with you, and then I want you to pause the video and work through the next 7. Okay, and then I'll then unpause it, and we'll talk about how to do those 7. But the first one, okay, it starts with an alarm clock, and it's drawing a 1/2 amp of current, and it's connected to a 120 volt circuit. And just in case that 120 volts sounds kind of like an interesting number, 120 volts is what your wall outlet produces. The normal wall outlet is going to produce 120 volts. All right. So if you know those two things, I want you to calculate the resistance of that circuit. All right. And this might be useful in case you're designing an alarm clock similar to this first one. You want to make sure how much resistance you need to provide for it. So in this case, I'm going to use Ohm's Law. I'm looking for resistance, so I'm going to use the resistance version of it. I know the voltage, it tells me it's 120 volts, and I know the current running through it is 0.5 amps. So to solve for the resistance, it's just voltage divided by current. So in this case, 120 divided by 0.5. So the resistance is going to equal 240 ohms. All right. And for all these 7 questions, literally, it is going to be the same thing. You're just using Ohm's Law to break it down. Okay. So with that being said, I want you to, if you could, pause the video, take about 6 or 7 minutes to work through these questions. When you're done, unpause it, and we'll talk about what the answers are. All right? So at this point, pause the video, work through the questions. So current, and while y'all are working through that, hopefully I'm going to write down kind of what we're looking for. Current, resistance, current, resistance, voltage, current, voltage, clutch. All right, so hopefully you've had a chance to work through all of these different questions, all right? And while kind of what I've been doing is I'm just kind of writing down what we're looking for. So we're looking for current in a couple of these, resistance in a couple of these, and voltage in a couple of these, all right? So Ohm's law, looking for current is, remember, I equals V divided by R. For resistance, it's V divided by I. And then, of course, once again, we're doing the same thing. And then for voltage, it's going to be the current. Oh, that's a really good I. Just in case you're curious, that is supposed to be an I. All right, and then resistance, V divided by I. Okay, now, at this point, we know, going through all these things, we can see what we need to solve for. So for the first one, just kind of working down, we start with the toaster. It's got 12 ohms of resistance and a 120 volt circuit. So V would be 120. All right, resistance would be 12 ohms. So looking at that, the current would be about 10 amps. Okay, I'm going to work through the first couple ones. I'm going to show the work, but for the other ones, I'm going to, well, I guess I'll show the work for all of them. I said I would do that during live class. All right, so same deal. Next one, we're looking for resistance for this subwoofer. All right, it says household voltage of 110 volts. Usually it's 120. So this is voltage in this case is going to be 110. All right. The current's going to be 5.5 amps. All right. Solve for that. You should get the resistance is going to be about, I believe it should be 20 ohms. All right. And that's exactly right. Okay. So right here, we're just using Ohm's law. Every one of these cases, we're using the same thing. We're identifying what we know, looking for the thing we don't. Okay. So in this case, found resistance. Next, this car battery, 12 volts. Is pushing charge through a headlight, and the circuit for that is only has 10 ohms of resistance. So in this case, the voltage is 12, the resistance is 10, so the current is going to be equal to, looking at it, 1.2 amps. Nice. All right, so already looking through this, halfway through, we're doing great. Next, got a Walkman. Oh my gosh, if you don't know what that is, that's the great-grandfather of an iPod. So you can thank the Walkman whenever you're walking around with your iPhone. So in this case, a Walkman uses a standard 1.5 volt battery. The resistance in the circuit we're not really sure about, but we know that it only uses a tiny little amount of current, which is 0.01 amps. So if I put the voltage is 1.5 volts divided by the current, which is only 0.1, we'll get that the resistance of this is a cool 150 ohms. All right, and remember the symbol for ohm is this omega. As you're wondering what that is, that's just the symbol for the ohm for resistance. All right. Next, this one is pretty much, it's very general. It just says how much voltage would be necessary to generate 10 amps of current in a circuit that has 5 ohms of resistance. Basically, it wants to know what type of battery should we buy if we want to get those settings. So in this case, I know that voltage is going to be equal to the current times the resistance. All right, so that means the voltage, the battery would need to be 50 volts to do that. Okay, and I know I apologize if it seems like going fast, but I promise these are very simple. Just plug them into the formula. If you have questions, shoot me an email because I'm happy to answer them at any point in time. Okay, now for the second to last question. A circuit contains a 1.5 volt battery and the bulb has a resistance of 3 ohms. This is a tiny little circuit. So to find the current, once again, you start with the voltage divided by the resistance. We'll get that the current flowing through that light bulb, that little tiny light bulb, is going to be half an amp. All right. And then for the last piece of this, all right, I've got an electric heater, and what it does, it basically passes current through a wire, a lot of current, and it is 100 amps, it's quite a lot of current, and it goes through a coiled metal wire, and it makes it very hot, and the resistance of the wire is very low, in this case it's 1.1 ohms. I want to know what voltage must be applied to it. All right, so in this case I'm solving for voltage again. I know that 100 amps of current are running through this, and I know it has a very tiny resistance, of, my apologies, it should be 1.1. All right, so very small resistance of 1.1 ohms. So if you go through and find that, you'll get that the voltage is 110 volts. That's how much it'll take. All right. Now, with that being said, I know I raced through those questions. All of them are practicing the same thing, using this law that governs how kind of electricity flows through a circuit and looking at different parts of a circuit. Okay. And we're going to get a little more complicated as we go through it. All right, this is very useful for those of you who are planning on maybe heading into engineering, specifically electrical engineering. Knowing how Ohm's Law work and circuits work is very important. All right, if you're also going into AP Physics C, this is going to be very useful knowledge when you get to the second part for circuits. All right, so with that being said, ladies and gentlemen, if you have any questions, what we just talked about, I know I went through it kind of fast, please shoot me an email, come see me during office hours. All right, otherwise, I hope you have a great rest of the day, and I will talk to y'all later.